How's it going, everybody? My name is Ron Sparkman, and I am the Chief Curiosity Correspondent for the Space Foundation Discovery Center. And today we have another incredible guest for Space4U Live. It is the one and only Dr. Graham Lau. He's an astrobiologist, but he is often referred to as the Cosmobiologist. And maybe we'll talk a little bit about the differences there, if there is any at all, in a few minutes. So Graham is the co-host of NASA's Ask an Astrobiologist, as well as a research assistant for Blue Marble Space Institute, where he's also the Director of Communications and Marketing for their social media, which is awesome. So social media guy like me. And we're going to discuss all that and more on today's show. So Graham, welcome to the show, sir.
Yeah, thanks for having me, Ron. Appreciate it.
Oh, yeah, man. Always glad to talk to you. And it's always really interesting conversations with you because of just your breadth of knowledge on so many cool things. So let's just dive right in with the first big question I always love to ask everyone, and that is, how did you get interested in space and science?
Yeah, that's a really fun question for me since I know the exact moment. I was 5 years old in 1988, and a movie came out called Young Einstein. This was a satirical comedy film from the 80s featuring a really good 80s music soundtrack of mostly then unheard of bands and starring an Australian guy who created this story of Albert Einstein being born in Tasmania on an apple farm and learning to split the Tasmanian beer atom to put bubbles in beer. So obviously it was, not true, but hilarious all the same. But I saw this in 1988, and I was 5 years old in the movie theater with my parents. I went home that night and did two things. One, I made my first guitar out of a shoebox with some help from my mom. And then the second thing is that I told her that I want to be a scientist. Seeing this comedy film that made scientists look like they could also be living people too, kind of in some way inspired me. Like I'd already loved science and scientists at that point, and then seeing that you'd have some fun with it too, and still talk about exploring the nature of the universe and exploring physics and things like this, really inspired me. So that night I decided I wanted to be a scientist. And so I kind of stuck with that through my life in various ways. And everyone's path is different. My path has meandered a lot. But certainly as a young person, my interest in space grew with things like watching Star Trek and loving Star Wars and reading things by Carl Sagan and getting more interested in what we can, think about, our place in the cosmos. You go outside at night and you look at the stars, and it feels like there must be more out there, that there must be more to this life. And so those kind of things really inspired me to get involved in some of the depths of the sciences and the philosophy of asking ourselves these really big questions about our place in the universe.
And so that, when we talk about astrobiology, for a lot of us, it's really one of the most fascinating things: life in the solar system, life in the universe. But to the average person, it kind of sounds like science fiction. So what does an astrobiologist like yourself do on a day-to-day basis for work? What is that science?
So I wouldn't say that there's like a single thing that an astrobiologist does. Astrobiology, to me, astrobiology is our quest to understand the nature of life in the universe. It's the quest to understand how life starts, how it spreads, how it changes through time, and how we can look for it out there if there is other life. And it's a culmination of lots of different ideas and questions we've had about ourselves in the cosmos for a very long time. But it's also a really interdisciplinary field of research, of understanding. So the sciences long ago broke away from being a study of natural history and natural philosophy and started being broken into these bins of, I study biology or chemistry or physics and geology, like all these different things. And people weren't speaking to each other in those different fields. You'd be on university campuses and someone in a physics department would never even see someone working in a biology department. And astrobiology necessarily has to break that mold. Astrobiology requires physicists and astronomers and geochemists and oceanographers and atmospheric scientists to speak to each other, because they're all coming towards the approach of understanding planets and planetary formation and the origins of life and the evolution of life and whether or not we can find alien life. These things require a lot of different skill sets, a lot of pieces of knowledge to come together. So from my side of it, I started off studying biology and chemistry, and then I jumped into astrophysics for a little while. And then I earned my PhD in geology, focusing primarily in the realm of geochemistry, geomicrobiology. So trying to understand how microorganisms affect their environment, and how the environment affects them, and how we can use this to look for life on other worlds in our solar system and in life in exoplanets from stars far away. And so every astrobiologist comes to the field a little bit differently. There are people out there who've gotten their degrees in astronomy and astrophysics and are really interested in studying exoplanets and using the next next space telescopes to look for signs of potential biosignatures in the atmospheres of exoplanets, say with like James Webb or another upcoming telescope. And then there are other folks who are doing things in like the geochemistry realm, like I have, who are going to places on our planet that present extreme environments or just unique environments where we can really study how organisms affect their environment around them and whether or not they're leaving signs of biological activity in those environments. From the Arctic to the Atacama Desert to the Antarctic, to various places around our planet that have extreme life working in weird ways. And there are people who also spend a lot of their time in the lab doing computational work, who use computers to try to better understand the potential for the origins of life and how life evolved through time. And so there's no single thing that an astrobiologist does. We're all doing many different things. And then for me, myself, I'm also a communicator of science. And so while I spend a good bit of time working on the science of astrobiology, I also spend a lot of time thinking about how can we communicate that science better to everyone so that we can all engage in this global conversation about life in the cosmos.
That's a heck of an answer, man. And I love the fact that we're seeing so many of the sciences now intertwine with each other. And I think obviously it was the only way forward, right? It was one of those things that had to happen. And as this has become a bigger and bigger thing, people like you, Dr. Grinspoon, all the other the science communicators that are out there that are sharing all this big science, it just gets the world excited about it. And there's so many cool things to talk about. One of them was you discussed the idea of the extremophiles, this life that can kind of live anywhere. A lot of people know them as tardigrades, water bears. That's one of the most popular examples. So when you're looking at something like that, how does that allow you to understand where we may be able to discover life in the universe or even within our own solar system?
Yeah, that's a great question as well. So extremophiles, I mean, it's kind of a weird definition of extremophile because right now a lot of things that we call extremophiles are only extreme relative to us. And so they can withstand temperatures that are different than our range, or salinities or pressures or things that are different than how we live, even though for a lot of life on Earth, we'd be considered extremophiles. But that aside, when we go out into the environment and we look in these extreme systems with high acidity, with high heat or very low temperature, it allows us to explore the kinds of environments that we find in places in our solar system and potentially elsewhere. So for instance, in my graduate research, I did some research in the Arctic on a glacier where we're studying the kinds of organisms and the kinds of geochemistry involved in bringing fluids from the subsurface through a glacier to the surface, and how we can use the processes happening there, the chemistry, the biology there to look for signs of life in places like Europa or Enceladus. And we can go to places like Yellowstone National Park, for instance, and look at something like Grand Prismatic Spring or another hot spring and look at the organisms that are thriving in these super hot fluids and maybe find ways using them to look for potential signs of past life on ancient Mars from long ago. Or by doing atmospheric biology, aerobiology, by trying to understand how organisms can survive in the atmosphere, it can help us to figure out whether or not there could be things living in the clouds of Venus. Or maybe we'll look out into the universe and we'll discover that a lot of exoplanets have things dwelling in their atmospheres. And so by studying extremophiles, it tells us how to better look into various kinds of environments for signs of life. And also, on Earth, like it's all of life on Earth is very beautiful and precious and has done a lot of great stuff. And I also like to think about just like the weird birds and insects and other creatures like that we often don't consider that much when we're talking about astrobiology, but they're also really important and can teach us a lot about potentials for alien life, especially more complex alien life, if we ever find it. But one reason that it gets a little bit more complicated with systems like your backyard is that there's a lot going on there. And so in extreme systems, there's fewer organisms, the biodiversity is a bit lower, it's easier to isolate things. But say you go into a rainforest and you have myriad creatures, plants and animals and fungi and all kinds of bacteria and archaea all over, it can be a little bit harder to kind of disentangle some of those signs of the biological process, at least for going out into the universe to look for life right now, until we can send humans out on interplanetary and then interstellar trips to go look for signs of life elsewhere. We're very limited on what we can actually look at and how to go find it. And so right now, extremophiles are a great bet for kind of finding those signs of life out there.
And so I do want to remind everyone, this is a live show. If you have questions for us, Graham's a wealth of knowledge, as you can obviously tell. So make sure to drop them in the comments below, and we'll get to some of them. So you mentioned Europa and Enceladus. For people that don't know, those are moons of Jupiter and Saturn. And whenever we look at Europa and Enceladus, we've got these two really particular places where it's got something that makes us want to go there to look for life. So can you talk a little bit about that and why they are two of the bigger candidates?
Sure, yeah. I mean, the icy moons of our solar system are incredible, and we need more missions. We need to go out there and look at them, and we're only really limited right now by funding and resources. I mean, we have the technology. A lot of us have the interest. Right now, it's just getting out there and doing it. But of the icy worlds of our solar system, there are a small handful that are highly valued targets right now for astrobiology, for looking for signs of life. Europa is one of my favorites. It's one of the Galilean moons. So it was one of the very first moons discovered outside of our own moon. Galileo Galilei in 1609, pointing his telescope towards the heavens, towards Jupiter, noticed these little stars moving around Jupiter, and then he discovered that they were actually moons orbiting Jupiter itself. And those first 4 other moons are the Galilean moons of Jupiter, and Europa is one of them. Europa is about the size of our moon, pretty close to it. So it's a fairly large moon in our solar system. And when we started flying by it, we used telescopes to look at it. We noticed that it had this kind of cracked, icy surface. And later on, with the Galileo spacecraft, which went to Jupiter, we discovered through the magnetometer on that there's most likely a salty ocean inside of Europa. And right now, we're not entirely sure how thick the icy crust on the outside of Europa is, but some of the better estimates we think are somewhere around like 10 kilometers, so maybe just over 6 miles thick. And then down below that is an ocean, and that ocean would be very deep if that's how thick the ice is. That would make the ocean somewhere in like that 60 to 75 kind of mile range, which is way deeper than our oceans here on Earth. There's a really cool figure you can find out there online that shows if you take all of the water on Earth in our oceans and lakes and rivers and pull that off and make a little sphere out of that water, the volume of water in that sphere from Earth would be less than the volume of water in such a sphere that you could make from Europa. And so Europa has a very large, a very voluminous ocean down below that ice that a lot of us want to explore. Here on Earth, at the bottom of our oceans, we have these hydrothermal vents, these big black smokers, where superheated ocean water, water from the ocean is going down into the crust over the mantle and getting warmed up, and then it's coming out superheated, several hundred degrees. And when it comes out, it's bringing out a lot of chemistry from the subsurface with it and providing a chemical and a thermal or temperature gradient. So changes in temperature very, very quickly and changes in the chemistry very quickly that allow life to thrive in those systems. We don't know if life can originate around hydrothermal vents or not. We don't know. Life might require dry surfaces of planets to start, for instance. There's a recent hypothesis by Bruce Damer and Dave Deamer suggesting that life needs dry environments to start as we know it. But maybe life started around a hydrothermal vent in Europa, and that'd be really cool. And if so, there might be a whole biosphere in this huge ocean under Europa's icy crust waiting for us to go find it. And so that's really exciting. We have another upcoming mission, the Europa Clipper, that a lot of us are super excited about. It's going to orbit around Jupiter and Europa together and do a bunch of flybys of Europa. It'll let us better understand the thickness of Europa's crust and actually get that number nailed down a little bit better. It'll also let us look at the surface of Europa to see if there are any signs of life from down in that ocean that could come to the surface. Or if the ocean itself is making it to the surface, it might let us explore some of the chemistry from that as well. There also is a slight potential that there could be plumes of water coming out of Europa. We've had a few papers now published over the past several years showing that there could be intermittent pluming of water coming out of the southern region of Europa. And if so, and it's coming from the ocean, that could be really cool. So for instance, with another moon, Enceladus, which I mentioned, which is also a high priority target for astrobiology, with Enceladus, we got really lucky with the Cassini spacecraft, which was orbiting around Saturn and did some really amazing work looking at the moons of Saturn and studying Saturn itself. And with Cassini, we got lucky. We discovered there was plumes of water, definite plumes of water coming out of the southern pole region of Enceladus from this region called the Tiger Stripes. And with the spacecraft, we were able to actually fly through those plumes of water to learn a bit more about the chemistry. And so with Enceladus, we know for sure that Enceladus has water down below. It's most likely in an ocean. And with Enceladus, we definitely know that there's plumes of water coming out. And so that's a great place for us to go look for potential signs of life from an icy world ocean in our own solar system. And so there have been proposals. Nothing's definite yet, but it'd be really cool in the near future if we could get another spacecraft to go there that's been developed specifically for flying through those plumes or even landing where those plumes are coming out to study the chemistry and to look for potential signs of biology. So Europa and Enceladus are definitely two of the cooler targets right now, but there's others in our solar system, but they're two of the really good ones.
And one of my favorite topics to talk about is the idea of panspermia. And not everybody really knows a whole lot about that, and who better to ask than you. So I love this one. And, this is one of the bigger ideas, and it opens up the possibility of life, not just in our solar system, but really across, the galaxy, across the cosmos. So can you tell us a little bit about that and what you think of it? Maybe is it a viable thing, or is it something that, maybe is more on the wishful thinking side?
Yeah, so the panspermia hypothesis is a really cool idea. The term was coined by Anaxagoras, so it's been with us for a very long time. Humans seeing rocks falling from the heavens as meteors and meteorites. I mean, we started wondering, could life be coming from the heavens as well? And the idea was tossed around a lot in various ways for a long time, but now that we have more powerful tools of science, we can really explore this idea of panspermia, which the word itself literally means seeds everywhere. And so the idea is that life could be transmitted from one planetary body to another, or maybe transmitted through the depths of space, in between star systems. And so it's a really cool idea. We don't have any evidence that panspermia has happened, but it definitely makes a lot of sense. And so people have been doing research on whether or not life on Earth, for instance, could survive a bombardment, an impact by a planetary object. So say a comet or an asteroid hits the Earth, it turns out that when some of that rock is thrust up in that process, some of it actually has escape velocity and will leave the Earth. And some of those rocks could actually contain life inside of them. And so life on Earth might already have been shot into space. For instance, there's a very good chance that there's ancient signs of Earth life in rocks right now sitting on the moon that got blasted off of our planet. And so it'd be kind of cool to go find those rocks and learn more about ancient life from Earth. Also, like with Mars, for instance, with Phobos and Deimos on Mars, Mars might have launched some rocks off long ago having life that could have landed on those moons. And so maybe some signs of ancient Mars life might be on those moons for us to find. The thing is, and then, life actually could survive the transit too. We've been studying extremophiles doing exposure experiments, for instance, outside of the space shuttle or with various satellites or on the space station, looking at how certain organisms actually can survive parts of the space environment, can survive the desiccation, the radiation, the cold. And so there are organisms that could survive that trip on a rock in between planets. And so, we talk about the origin of life on Earth. And we have good reason to think that life did start here and then evolved here. But there's also, there's no reason that life couldn't have started on Mars or Venus first and then been brought here. And so it's a worthy venture for us to also consider this idea of panspermia. And for me personally, I think the idea is super cool. It's one of the things that kind of got me into astrobiology specifically early on in my studies as a student. I was in an undergraduate degree program in biology, taking a course in ecology. And we had to do a project, a presentation and a paper on some topic that interested us in ecology. And I talked the professor, a great guy, into allowing me to do my project on panspermia since I wanted to learn more about it. And so the idea of researching that kind of got me more into these ideas of trying to understand life in extreme environments and whether or not life could survive in space and things like that. Now, when it comes to whether or not life could have come here from another star system or another galaxy especially, things get a little bit harder there. It's possible, but the probability starts to fall a lot in those cases because of the distances. So even with these hypervelocity objects, so things like asteroids and comets, they're actually moving really, really, really fast in space. So fast that we can't even make a gun on Earth that can fire a bullet at a hypervelocity kind of rate like these things are when they come down and they hit. And so these large impactors have a lot of force behind them. It creates a lot of pressure, which allows it to blow things off in escape velocities like that. And so things are moving very fast out there in the cosmos. And we know now, like through Oumuamua and other objects, that things could actually come into our solar system from other star systems and go back out again. And so maybe through time, things have been brought here, but the time span starts to drop a little bit. And the problem is we don't know how early in the history of the universe life could have started. Maybe life needed a certain amount of enrichment of larger elements from the burning inside of stars and supernovae explosions and things like that before life could have started in other worlds. And so maybe part of the reason we haven't found other life yet is that we're part of the first life kind of showing up in the galaxy. And so maybe life in the galaxy isn't all that old if there is other life out there. And so that kind of also makes it hard for life to be then transmitted through the galaxy to here. But I wouldn't say it's impossible because, like I said, it's a very cool idea. It makes a lot of sense. And we don't have any evidence that it's actually happened, but we have good reason to think it could.
And so this is a perfect day to talk to you because this is a great anniversary. This is the anniversary of Kepler finding the first Earth-like planet in the Goldilocks Zone around another star. There's a lot to unpack there. So you want to talk a little bit about that one, the Goldilocks Zone? What is that? What does that mean? Does it mean it just for Earth, like it's life as we know it? What does that mean? And what does that mean for someone like you that's an astrobiologist, the first planet around another star that could possibly harbor life?
I mean, it's extremely exciting. When I was a kid, we didn't know other planets were out there for sure. People for a long time have thought there should be other planets, but why wouldn't there be other planets? But it's only been a couple of decades now that we've actually had evidence, like confirmed evidence that there are worlds around other stars. And now we keep finding more and more and more. And like you said, we're now finding some that are roughly the size of our world, orbiting in a region around a star that we call the Goldilocks Zone. And I'm very glad, by the way, to hear you say Goldilocks Zone and not habitable zone. I hate the word habitable zone of the term. It's not helpful. It's very presumptive. Because we just don't know. Maybe we'll discover, maybe once we start finding alien life, if it's out there, maybe we'll find out that life in the Goldilocks Zone is actually pretty rare. But when it comes to this, so the Goldilocks Zone is this region around a star where theoretically, if it's a terrestrial planet that has a solid surface, based solely on the starlight alone hitting the planet, that the planet's surface might then have enough heat for liquid water to be stable at the surface. So it doesn't take into account atmospheres or anything like that. It's just assuming that you have a solid spherical object that on the surface of that object, if it's rocky, it's absorbing sunlight, that it could have water at the surface. But that's also a really important thing for us to know, because if there are other terrestrial type worlds in this region around stars out there, then they might be the ones that likely also have oceans. And that could be really important then for looking for potential alien life. And so a lot of times we get really excited because, life as we know it survives on this world with liquid oceans in the Goldilocks Zone of our star. And so maybe we'll get really lucky and find it out there. But there's also a potential that we'll discover that a lot of worlds inside of the Goldilocks Zone are more like Mars or more like Venus. They either have, very thick atmospheres and runaway greenhouses and can't harbor life at their surfaces like we do here on Earth, or they'll be, small or very cold at the surface, have very little atmosphere. Maybe they won't have plate tectonics or magnetism to hold the atmosphere in. And so there's a lot of issues with assuming that life would only be found on planets in the Goldilocks Zone, but it's still a really incredible place to start looking. Since we have an example of life here, we know what to look for if we're looking for life here to some degree. We can start looking for that kind of life on those exoplanets in the Goldilocks zone around other stars, and we can do it now.
So it's difficult for me to go off of this because it just starts bringing more questions to mind. And so for those that don't know, our guests that are on Space4U Live also do our Space4U podcast. So there's a lot of questions we didn't get to do that definitely you're going to hear a little bit more about there. But there's a couple other things I want to talk to you about that I know that you're passionate about before we see if there's any questions that anybody has. And, as people can see in your name there, you work with Blue Marble Space, and you do a couple different things for them. So can you tell us what you do? As I know you're a research assistant, you help them out with social media, like communications. Tell us a little bit about that work.
Yeah. So I am the director of communications and marketing for Blue Marble Space. So Blue Marble Space is kind of a larger umbrella nonprofit that tries to help scientists who have a vision for sustainability, for the betterment of our planet, for space exploration, for Earth system science, for building a better world, and who want to get involved in entrepreneurship. We kind of help give them the keys to do that. We help them get involved in it. And so through Blue Marble Space, we have a lot of initiatives. Things like SegaNet, which is an astrobiology social network, is where we stream the show Ask an Astrobiologist with NASA Astrobiology. We also have SciWorthy. So SciWorthy.com is a website where several of us are writers and editors, and we take modern, recent research literature, peer-reviewed literature, and then we give it a synopsis. We basically explain it in common language, what's going on inside of the research. We also have Green Space. It's a microgreen farm in Pennsylvania where we're growing microgreens. We sell them online. We're actually open to the pandemic, which is awesome, so we can still grow and sell nutritious food for people during this time. And then also we have the Blue Marble Space Institute of Science. So that's our research branch, and I'm a research scientist with BMSIS. And so through that, we have well over 40 scientists now who are doing research in institutions or who are just affiliated with us and are doing their research through our institution. So much like how the SETI Institute or the Planetary Science Institute has scientists, so do we. And we do the same thing. We can apply for grants to fund our research and to help us continue forward in our journey of being scientists through Blue Marble Space. And so we're doing a lot of really cool things in our organization. And so it's weird. It's like I've been like jumping through all these different hats that I have to wear now in my career, from being a geochemist and a research scientist to being a social media guru and handling that kind of stuff to handling all of our emails. Just yesterday, we closed the applications for our summer internships for the organization. And so now my job is to go through all of the applications, organize them, and get them to all of our scientists. For my own projects, I'm going to help mentor 2 projects. I had about 40 applicants for those. And so it's going to be a lot of work now going through and choosing the right ones for this summer to work with us. My 2 projects, one involves science communication. So I'll have interns who are writing about science, who are sharing science through social media with me, who are exploring the science of science communication. And then we also have another project, myself and Dr. Andrew Rios, that we're hosting through the Center for Life Detection at NASA Ames, where we'll have students doing some research in biosignatures and signs of life and helping us build the knowledge base for the Life Detection Forum, which is a web tool we will be using to kind of store all of our knowledge about biosignatures that are out there that might be useful in future missions for NASA.
That's a lot of exciting stuff. It looks like we actually have a question before we continue on here. And this comes from Twitter, Periscope. Jim, and I hope I said your last name right, Jim Gepperith, I think is how you say it. How would you like to see robotics used differently, if at all, in the exploration of space, looking for life, that kind of thing?
Yeah, great question, Jim. So first off, if at all, definitely, yes, please, let's use robots. I want to send people out into space. I would love it if we could do that right now. I would love to see people go on a mission to orbit Venus and look down at the clouds from above. And ever since I was a kid, I've dreamed about walking on Mars. I'd love for us humans to have outposts throughout our solar system. I'm currently reading the Expanse novels, and I love this idea of a future where we've started living on and in the icy worlds of our solar system, the asteroids of our solar system. But at the same time, right now, robots allow us to do a lot more. So human space exploration is fairly expensive right now, and it's hard with our current resources and our current political environment to get more humans out there to explore now, even though a lot of us really want to advocate for that and make it happen. But there's a lot that we can do with robots. So sending out more and more robots is awesome, and I love it. I'd love to see more missions that kind of utilize out-of-the-box thinking. So there are other ways for us to do robotics. So for instance, Marco, the Mars Cube 1 satellites that were sent out recently is a great test. I'm glad that we have a helicopter going out now with the next Mars rover. The Dragonfly mission coming up is going to go to Titan and fly around with a little drone. These things are cool. There's so much more we could do with those kinds of ideas. And some of the ideas coming out right now from younger people in the space exploration sector who want to send origami robots out there that can unfold and do cool things is really awesome. I'd like to see robotics used to a much fuller extent to really start exploring more of the worlds of our solar system. We've only ever had one spacecraft fly by Neptune and Uranus, and that's a bummer. We need to get out there and continue the mission and go discover more. There are icy worlds around Uranus and Neptune for us to go explore. Triton, for instance, is a great one that a lot of us want to learn more about. And so I'd love to start seeing some more missions being sent out to all these other places in our solar system. I'd also personally, I don't see a reason why we can't send out more missions like the Voyager spacecraft, Voyager 1 and 2. They originally were intended for the grand tour of the outer solar system, or what was the outer solar system then, the four gaseous giant planets. Now we know that our solar system probably extends much, much, much further, and we might even have other planets out there to explore yet. But I'd love to see maybe like every decade or every 25 years, humans sending a probe out to explore interstellar space. Now that Voyager 1 and 2, even though they're still very much inside of our solar system, they are in interstellar space all the same, but they don't really have the ability to study that space very well like we would want to if we had missions designed for it. So I'd like to see some grand scale missions sent out by people who don't intend to live until the point of seeing the rewards of those missions. So like someone who plants a seed of a tree, knowing full and well that they might not have the chance to ever really enjoy the shade of the tree or see its beautiful foliage. I think we could have a larger vision of space exploration where we can send out some long duration missions intended to last 40, 50, 100 years to really start exploring interstellar space. And it also, I think a lot of us would love to get a spacecraft to another star. But to do that, we need better propulsion, we need support, we need resources, we need funding. And so it'd be really cool to see something like Project Starshot or one of these other things get off the ground and really happen during our lifetimes, or at least to start happening so that, during my son or some of the coming generations' lifetimes, they could see these things happening.
Man, it's been so exciting talking to you today. And again, there's just so much more to go over. There's a lot of different projects that you're also involved with, and we're going to touch more on those whenever you guys check out the Space4U podcast. And Graham's going to be doing that with us soon. But go ahead and give us the places where people can find you on social media, your website, Blue Marble Space, all that fun stuff, so they can check out all your hard work.
Absolutely. So bmsis.org is our website for Blue Marble Space Institute of Science. You can find me there pretty easily. And then if you go out into the social media realm and Twitter and Instagram, I am Cosmobiologist. That actually happened by a fluke. I was creating a blog on Blogger, of all things, over a decade ago, and I needed a cool name for it. And I wanted to call it an astrobiologist dream for me to pontificate on my thoughts of the universe for where I was in my life then. But astrobiologist was already taken for Blogger accounts, and so I changed it to Cosmobiologist. And so you can find me out there as Cosmobiologist on Twitter and Instagram. You can find my website at cosmobiota.com, so COSMOBIOTA.com. So biota is a word that means life. We are biota, particles floating in the atmosphere of bacteria and fungi. That's biota. And so when I coined this term cosmobiota, I use it to be a term to mean the living matter of the universe. And so you can find me that way for sure. I love chatting online. I'm pretty available to lots of people. I love having conversations about science and science fiction, pseudoscience, philosophy, all kinds of things. So yeah, reach out.
And Graham, it's always entertaining talking to you and always exciting and educational. Love it. Thank you so much for coming on today. You were an amazing guest, as any time we've ever had a conversation, man. It's always incredible. Thank you so much for coming on.
It's always a pleasure, Ron. Appreciate it, man.
Absolutely. And that's going to conclude this episode of the live edition of Space4U by Space Foundation. So make sure to check out the podcast online and keep your ears open for that. There's going to be some really amazing ones. Actually, we just dropped one this morning with Dr. Uliana Hordisky, who is going to be one of our hosts along with Graham for an upcoming event that we're going to be doing at the Space Foundation Discovery Center for our Space After Dark events called Climate. So check out more on that on our website, discoverspace.org. As well, you can also find the Space4U podcast on www.spacefoundation.org. And if you haven't been checking out all the educational materials and incredible videos that we have been putting out, again, check out www.discoverspace.org. And on all those outlets and more, it's our goal to inspire, educate, connect, and advocate for the space community. Because at the Space Foundation, we will always have space for you. Thank you so much for joining, and we'll see you on the next episode.